All right, hi everyone. Ooh, that's nice. Let's get started. So welcome to Power BI Architecture, Best Practices, and Performance Tuning. My name is Suri. I'm a program manager on the Power BI team over in Redmond. And today we're going to talk about one thing and one thing only, which is how to take Power BI and make sure that your dashboards and reports are performant and that they scale, right? There's going to be a lot of good content we have for you today. A lot of this content is actually never before presented or written down. It's going to be the basis for one of our performance white papers coming out in a few weeks or a few months. But I'm really excited to be able to present this to you guys today here at Ignite Australia for the very first time. So why do we care about performance, right? Put simply, right, performant reports are delightful to use, right? Time and time again, research has shown that there's a very tight correlation between performance and usage and delight for end users. And then the inverse is also true, right? So no one, well, this is a bit of an exaggeration, right? But as performance worsens on your dashboards and reports, you're going to see less and less uptake, less and less adoption, fewer people using it, right? So how are we going to ensure good performance? Put simply, what you want to do here is understand the tools at your disposal in Power BI and all the data sources that we connect to, and then make sure that we use them properly. And in particular, make sure you're thinking about these things, not just at the end of the development process when you suddenly realize that things are slow, but you're really thinking about these things all the way throughout, right? You're going to start by thinking about performance, and you're going to think about it throughout the life cycle, okay? So quick agenda today. We're going to start with a 50,000-foot view of Power BI and the different components that we connect to, okay? And then from there, we're going to kind of zoom into each of the individual core components where the time might be spent. And we're going to take that opportunity to talk about some best practices, some performance tuning you can do, and things like that, just based on building the product, the expertise we have from building the product, but also the expertise we have from working with customers worldwide. So kind of zooming into where the time could be spent, we're going to talk about the data source, right? How you connect to data is going to be very impactful on the performance. We're going to talk about the gateway, right? This is the bridge between the data source and the cloud if it happens to live on premises. We're going to talk about network latency, right? The time could be spent in the network itself as part of the HTTPS traffic. We'll talk about that. And then finally, we're just going to wrap this up with some all-up best practices. Okay? So let's start with the view from 50,000 feet. Okay, so we're going to start with the Power BI desktop clients, right? That's where you do your advanced authoring. You're going to connect the desktop clients to our data sources, right? We support over 70 or 80 data sources. And these can live either on the cloud or on premises, right? Once you're done with your report authoring in the Power BI desktop client, you're going to push that into the service, right? So this big orange block on the right is the service. And if you want your dashboards and reports to update in the service, and you're using a cloud data source, the service can talk directly to that cloud data source. That's the arrow at the top. Or if you want the service to refresh against the on-premises data sources, you're going to have a gateway in between, right? And that's just going to be the bridge between your on-premises data source and the service, okay? And then finally, people are going to have to consume the reports and dashboards that you build in the Power BI service. And so that's the final step here, which is consumption by end users, right? They can hit this using their web browsers. They can use our mobile clients and talk to the service that way, but regardless, they're going to be seeing these dashboards and reports, right? So now that we have this 50,000-foot view, we can ask ourselves, okay, if you want to think about performance, if you want to think about how fast these dashboards and reports take to load, where is that time actually being spent, right? If you hit a dashboard and you get the little spinny, where is that time actually being spent? So at a high level, right, your time can be spent in the data source. So you hit the dashboard, right, and then especially if you've connected to the dashboard, if you connect to the data source via a live connection or direct query, the query is going to actually go to the underlying data source, and the data source is going to think through and actually have to process that query and return with the right results. So the time can be spent in the data source. The time can also be spent in the gateway, right? Being the gateway means being that bridge. That means kind of taking the queries that land from the Power BI service, sending it to the data source, and then coming back and relaying the data from the data source back to the service. It's a very intensive operation, so it can be spent there. It can be spent in the network, right? All of these red lines here are network requests, and those can end up taking a long time. And finally, it can be spent in the actual Power BI service itself, which is to say, right, the Power BI service has a lot of metadata that it tracks about users, which in turn we have our own databases for. It's making a bunch of calls to AAD. Time can be spent there, or it can also be spent finally in the underlying clients, right? Chrome is going to take the JavaScript and the HTML that's sent over by the Power BI service. It's going to have to render that, and then same with the mobile clients. So that was an overview of where the time can be spent. And so what we're going to do now is actually zoom into each of those little red boxes and talk about some more, and kind of drill down into that and talk about some best practices there. So the first thing we're going to talk about is connecting to your data, right? And this is going to be answering the question of how much time is being spent in your data sources, right? And actually, we start this one first because we find this is actually one of the most consequential places where time is being spent. Like if you were to if you're going to chart out how much time is being spent in each of these locations, what we typically find is the data source tends to be the biggest culprit. Okay? So the data source, right, can be either at the top, they can be cloud data sources, or at the bottom, they can be on-premises data sources. And there's also a bunch of different ways to connect to these data sources. So that's what we're going to talk about now. Okay? So quick review. When we look at how Power BI connects to your data model, we kind of see the world in one of two ways. The first way is what we call imported models, right? So in this case, what's happening is you connect to a data source. You can actually be copying either a subset or the entire data source into the Power BI desktop client, and that eventually makes its way up into the service, which is why we call these cloud models sometimes. And in this case, the data set, the metadata for the data source and also the underlying data is all stored in Power BI. And when you connect in the Power BI desktop, right, you get these options here, import and direct query, and then you're going to see that's the first option there. And next, there are external models, right? So in this case, the data is stored not in Power BI, but in the external data source itself, right? The metadata might be stored in Power BI, but ultimately the data is stored in the external data source. And so here, we tend to refer to these as either direct query or live connection in the case where you connect to analysis services, right? And that's the second option there when you go to connect to data in the Power BI desktop clients. And so the question is, how do we decide when to use one or the other, right? And what are the performance implications of that? So here are some key factors to consider when making this decision, right? So the first thing you're going to want to consider is model size and complexity. So the key number to remember here, right, is that if you're importing the model, the limitation right now for Power BI is going to be 1 gigabyte. If your model is greater than 1 gigabyte, you're not going to be able to take that model and import it into Power BI. If that's the case, and you need models greater than 1 gigabyte, you're going to want to use the direct query, the live connection, so that you can use your own data source and have more control over that. Next is data update frequency. And here, again, with the import models, you can only refresh up to 8 times a day. If you want data freshness, more fresh data than that, you're going to want to use direct query or live connection, right, the external connection. There's also the question of active concurrent users. So how many users do you expect to be viewing a particular model at any particular time? And here, with our import models, you're going to be able to this in general will scale out to what we've seen in practice is a few hundred users hitting a model at the same time, which is quite a bit, right? But if you do expect more concurrency than that, if it's a particularly large deployment of Power BI, then we do highly recommend that you do a direct connection to the underlying data source, and in addition that you make sure the data source itself is able to handle that level of concurrency. So up until now, I've really made a lot of caveats for the cloud import case. But there is one big advantage with the cloud import case, and that's query latency, right? So when we talk about query latency, what we mean is how long does it take between when Power BI visuals make the query to get the data for the visuals and when the data source itself returns with the visuals, the data for the visuals. And so in this case, what we see is that import models are fantastic at this, right? If you have that model imported to Power BI, and that model is inside Power BI, what we actually do is we run an instance of analysis services on top of that model, right? And it tends to be very, very performant. It's very hard to get this to not be performant, okay? So with the import case, your query latency is going to be very low. Another factor there is that the model itself lives in the cloud very close to the rest of the Power BI service, and so the network latency there is low as well, and that's kind of part of the reason why query latency is low for these cloud import models. For external models, the bets are kind of off, right? If you have an on-premises model, certainly, you're going to be making a lot more network requests, potentially to locations that are fairly far away from where Power BI is located, right? It's going to have to go through a gateway. And in addition, your underlying data source may be taking more time to process these queries. And so this is kind of a really key thing to take into consideration. If you can import, you're going to want to highly consider it. So now we're going to drill into each of the different types and just talk about some more characteristics and some best practices here. So again, for cloud models, right, these are best for small to medium models under 1 gigabyte with moderate concurrent usage. Again, about fewer than 200 or 300 users simultaneously using that report, right, which is a pretty large amount. So just a reminder of what that kind of looks like. Going back to our architectural high-level diagram, you're going to have these data sources. They're at a scheduled interval that you choose. These data sources are going to be, a copy of the data is going to be pulled into the service. If it's a cloud data source, like you see above, it's going to go directly to the service. Rather, the service is going to reach out directly to the data source, whereas if it's an on-premises data source, it's going to go through the gateway. But nevertheless, you're going to have a copy of that data in the Power BI service, so that when you go hit a visual, when you go to a dashboard or report, those queries are going directly against an instance of analysis services we have running underneath the covers. And so that's going to make your reports and dashboards be pretty snappy and pretty quick. With cloud models, right, we can talk about we can zoom into the characteristics. Some of this is going to be a bit of a review from what I just said, but query latency, right, is going to be low. That means if you hit a dashboard, if you hit a report and you're filtering around, the performance is going to tend to be pretty good. Data freshness, right, updated up to 8 times a day based on a schedule you decide. The data model size limit is going to be 1 gigabyte, and the number of concurrent dashboard and report users is going to be, I say throttled here. We do put an eventual throttle on it, and that lends to the few hundred concurrent users that we see in practice. Right? So next, we're going to talk about live connection to SSAS. So this is a version of the external data source connection, but in particular, we use the term live connection to refer to the case where you connect to analysis services that you have either in the cloud or on premises. Right? So here, this method is best if you have any of the following requirements, right? If you have large models greater than 1 gigabyte, if you have the need for frequent data updates, more often than 8 times a day, for example, scheduled refresh won't cut it for you, so you should consider live connection. Here in particular, what Power BI does is it's constantly querying analysis services to make sure that the dashboards and reports are up to date with whatever you have in analysis services. So as long as you make sure analysis services has the latest data or is refreshing at the cadence that you require, then you're going to be able to have more frequent data updates. And finally, if you have the need for high concurrent usage, right, if you anticipate more than a few hundred users, you're going to want to use SSAS and actually make sure that the underlying instances of analysis services are properly set up to handle that sort of load. Okay, so just to kind of walk through what that looks like based on our model again. So with a live connection, when a user hits a dashboard or report, those queries are going to be made against analysis services that you either have sitting up in Azure or that you have on premises. The queries will be channeled through the gateway if necessary. Okay, and in addition to that, when you have tiles set up on dashboards, what we're going to do is every 15 minutes, we're going to make the queries for the tiles you set up on the dashboard. So we're going to preload them into our system, and this is just a performance thing. Right? This is going to help you render that dashboard immediately once a user visits, instead of having to make those queries on the fly. Okay, so let's drill down to this fact table again. We have our target scenario, which is live connection to SSAS. This comes in 2 varieties, like I mentioned, on premises and Azure. We talk about query latency, right? How long it takes for those queries to come back from analysis services. For on-prem, this is a bit of a generalization, right? We call this medium. SSAS, because it's loading the models into memory, tends to be pretty quick, pretty snappy. But the reason it's medium is because the data might take some multiple hops through the network. It has to go through a gateway, and so that, in general, tends to add to the query latency. Right? Over on the right there, for Azure, we labeled this as low. Again, a generalization, but this is just to account for the fact that analysis services in Azure, especially if you set it in the same data center, just requires fewer hops to get from Power BI to analysis services. Right? The data freshness, again, here Power BI is going to be constantly making requests in real time to analysis services, and so the data is as fresh as you've configured it to be in analysis services. That's why we say depends. And the data model size limit, here again, this is limited by the data source or the analysis services, well, I guess it's the analysis services model size that you set up. So as big as you want to make it, you can make it. And finally, number of concurrent users. Here, this, again, scales with the machine configuration. So you're free to scale this up as much as possible. Power BI will be OK with that because it's ultimately just making these requests to analysis services. OK? Some additional specific guidance for SSIS, and this is starting to get into analysis services performance tuning, which is a little bit out of scope of this presentation, but still just some high-level things to call out. One, you do make sure to scale up your SSIS instances as needed, right? SSIS is the one now handling the load, handling the queries, and so for example, the typical guidance tends to be for those machines running SSIS, you're going to want to make sure that RAM is greater than or equal to 2.5 times the size of the models for a full processing operation. And the reason it's 2.5 times is we keep a model in memory for the previous version, so to speak, a model in memory for the next version that we're processing, just to make sure we have a fallback. And then there's 50% kind of just for the additional operations that happen throughout the course of processing. So there's plenty more guidance on this sort of thing. It's linked in the documentation at the end of this deck. You can go ahead and go online and download that and take a look. Another key point of guidance here is to use SSIS 2016. And there's a specific Power BI reason here, which is that the queries that Power BI sends, SSIS 2016, tend to be far more optimized, well, are far more optimized than the queries that are sent to previous versions of SSIS. Sometimes we'll even see, it's a factor of 2 or 3 in terms of performance. And so definitely be sure to upgrade to SSIS 2016 if you're going to be doing these live connections and you're interested in performance, which you should be. Okay. And next, this is just general good practices with analysis services, right, is to make sure you set up performance monitoring. So here in particular, right, we're showing performance monitoring in Windows. Got to make sure to kind of set a baseline, right, see what the baselines typically are in terms of CPU and memory usage, and then you get a feel for the performance at the baselines, which gives you a feel for what happens at the peaks and troughs of the performance. Okay. And finally, we can talk about direct query. So this is the external connection to data sources that are not live connection, right? And here our guidance is, this is really for your workloads that have a near real-time requirement. This is, I absolutely need to, in Power BI, show the very latest data, okay? But and this is the big caution here, you really need to be cautious about the caveats that come with direct query. And in particular, when we have customers that talk about Power BI being slow, very often it turns out that this is actually because they've set up direct query against the underlying data source, and the underlying data source is being slow. So that's why we're being fairly cautious here. Now, in the direct query case, of course, when a user comes to a dashboard or report, the Power BI service makes those queries to the underlying data source. The data source is going to process those queries. It's going to return with the data. And in addition, right, the same thing we talked about in live connection is true for direct query, which is that every 15 minutes, your dashboard tiles are going to be kind of auto-updated by Power BI in order to just ensure good performance on dashboard load. Okay, so back to this table. For query latency, we've labeled this high. This is a generalization again, but we labeled this high for both on-premises and Azure. So on-premises, obviously, you have the additional hops, and that's still valid for direct query in addition to live connection. But here, in addition, what we tend to see, and this is the reason why query latency is labeled as high for both on-prem and Azure, is we tend to see that the underlying data sources can be fairly slow at returning the information for the queries that Power BI is sending. And so we've labeled it as high there. The data model size limit, here again, limited only by your data source. And same for the maximum active concurrent users. It's going to vary on your data sources limits. Okay, so general guidance for direct query. The first one, and this is one that we cannot stress highly enough, you're going to want to make sure that in the desktop, right, when you first are authoring the support, that in the desktop, the performance with interacting with these visuals is reasonable, right? We recommend 5 to 10 seconds. This performance, especially when you're connecting to an on-premises data source, the performance you see won't include network latency, right, for the most part, at least as much network latency as when you connect via the service. Your performance here is not going to get better in the service. That's the ultimate key goal here. So the key takeaway here. So you're going to definitely want to test this in desktop first. Next, understand direct query specific constraints within Power BI itself. So when you decide to use direct query, unfortunately, there are just a few or a number of limitations that are direct query specific. For example, not every data source is going to support direct query today. Some only support the data import option. You're going to be lacking a little bit of time intelligence, limited to a single data source, right? You can't mash up different data sources together when you decide to use direct query. You can have limited DAX functions, especially when the data size starts to increase, and no bidirectional filtering. There's actually an entire list in the full deck. But just be aware that these are limitations with direct query if you decide to go down this route. What you don't want to have happen, right, is you start going down the route and you realize something you need, something you depend on is actually a limitation, a fundamental limitation of direct query. And finally here, be sure to understand the data source limitations and the load implications that you're going to be placing on the underlying data source, right? And here the guidance is, it's hard to give blanket guidance across all the different data sources that we support for direct query. But here in particular, right, we can take a look at SQL Data Warehouse and notice that there is a limit on concurrent queries based on deployment size. So you're going to want to be very conscious about this because in the direct query case, right, Power BI is going to be making all these queries to SQL Data Warehouse. And if you start hitting these limits, it's going to show in the performance of the Power BI service. Okay, so that was a lot of information. We want to just kind of quickly summarize the guidance, right? Turn this into sort of a flow chart. So first off, consider import. Can you import this data set into Power BI? And the reason why we start with this is, as I mentioned before, the query latency, right? If Power BI has this model in memory, in its own instance of analysis services, this tends to be very, very fast. But of course, here again, keep in mind the caveats. You have small models, you have model size limitations of less than a gigabyte. You have medium concurrency needs, and you also have infrequent data updates. Okay. Next, consider, can you create a live connection to SSAS? Right. Here again, SSAS is going to be processing this in memory. It's going to be fairly snappy, and here also, now you're going to be able to use larger models based on how you scale SSAS. You're going to be able to cater to higher concurrency needs and also deliver more frequent data updates if necessary. And then finally, only consider direct query if the first two options don't work for you. And here, typically, we see this happen, again, if you have a near real-time requirement, but also be aware of the caveats if you go with this approach. Okay, this is kind of the fine print slide, we'd like to call it. So basically, there are some additional factors here that you should consider that kind of lay on top of the things that we just talked about. For example, the query complexity. If you have very complex visuals, it's going to change the dynamics. It's going to kind of potentially slow down performance across the board. If you set up row-level security, and we'll go into a bit of an example about this in a second. Network latency we'll talk about in a second, but also usage patterns, right? If you expect users to be mostly using dashboards and just hitting the dashboard and leaving, right? A lot of times they're going to hit that cache that Power BI is building. And so that's going to have a different performance characteristic than if you expect your users to be clicking into reports and drilling around, right? In the latter case, that's going to be sending a lot more queries to the underlying data source if you have direct query set up, for example, and that will make your scaling story a little bit more challenging, right? And so just be aware of the usage patterns that you expect in your organization. Here's an illustration, right, of some of the additional scalability considerations. One of the kind of sub-points about this slide is that some of these factors can be multiplicative rather than additive. So let's illustrate what I mean. So suppose you have a dashboard, and you've connected that dashboard to a model that's doing live connection against SSAS on premises, and you have 3 tiles. Right? And so what that means is every 15 minutes, Power BI is going to be making 3 queries over to analysis services just to update those dashboard tiles. right? And of course, that's going to scale linearly as you add more visuals. So if you have 6 visuals every 15 minutes, we're making 6 different calls. But suppose you turn on RLS, row-level security, such that you have different segments of your population seeing different things on their dashboards, right? So what we're going to do in that case is actually we're going to be making multiple requests to that cache for each segment of that population, right? Because they're going to be seeing different things. We need to have different caches for those. In the extreme case, right, if you have every individual user seeing different things, we're going to be making a cache request every 15 minutes for those individual users. And so, again, this can quickly multiply to increase the load on SSAS. Okay, so next we're going to talk about gateways. It's another place where we see performance bottlenecks a lot. And we've been talking about gateways a little bit in glancing, but just to reinforce the fact that gateways, right, only needed if you have an on-premises data source. Sits as the bridge between the on-premises data source and Power BI service. What this actually looks like is you install this on a machine on premises, and it kind of acts as a bridge. So Power BI sends down queries to it. It relays these queries to the data source. The data source returns the data, and then it relays that back to the Power BI service. So this is not an easy task. And of course, if this machine can't handle the load, it's going to build up a backlog of those queries, the data to send back, and you're going to see your performance be impacted. Right? So some best practices here with respect to performance. Always use the on-premises data gateway. So this is the installer. When you install the gateway for the very first time, you have 2 choices. Right? You can use the on-premises data gateway, or you can use the personal gateway. The personal gateway we really just recommend for if you're in there playing around, trying things out for the very first time. Otherwise, use the on-premises data gateway. It's going to deliver a lot more performance monitoring features. And just in general, for anything production ready, for anything at scale, please use the on-premises data gateway. Here again, be aware of the minimum system recommendations, right, for the gateway. So 8 gigabytes of RAM, we recommend, we require 8 gigabytes of RAM, 8 CPU cores. We recommend Windows Server 2012 R2. We also recommend, by the way, that you kind of keep this machine dedicated for use as a gateway, right, not as a development machine that also doubles as a gateway. And also make sure, of course, that the network connection is very reliable on this machine, since its main job is to serve as a conduit for the network. So definitely don't set this up on a Wi-Fi machine that might be moving around. Make sure you keep it wired. Right. Set up performance monitoring on the gateway. So here, this could be a presentation in and of itself. But in general, the guidance here is, right, the gateway has, installed on a Windows machine. You can use performance monitoring on the Windows machine to see what the CPU usage is, what the RAM usage is, what the network bandwidth has looked like. And in particular, there's a great guide that I have linked at the end of this presentation, which walks through how to do this setup, how to look at the performance metrics, and also how to even hook that up into Power BI, so you can make reports like these to show what your CPU usage, what your RAM, what your network bandwidth has looked like over time. And so this is really helpful just to understand a baseline of what your gateway is doing, and then to see the peaks and troughs, right? And then here, once you have a sense of the performance, once you have a sense of the load of your gateway machines, scale up and scale out as needed, right? If you're hitting your RAM limitations, add more RAM. Otherwise, if you have multiple data sources on a single gateway, one way you can scale out by actually splitting up the different data sources on different gateways. We don't, unfortunately, yet support having a single data source on multiple gateways, but we've seen in practice that if you have, if you kind of limit individual data sources to individual gateways, that tends to do the trick. One final tip here, in terms of scaling out, we do recommend, and this is a bit of more of an advanced tip, that if you have scale out needs, that you actually separate the gateways that do direct query versus the gateways that do import. And here, this is just owing to the different characteristics of refresh for direct query versus refresh for import, right? With direct query, you're going to have these 15-minute refresh cycles, and you don't want that stomping over the imports, which might take longer, but which happen at a more infrequent cadence. Okay. So next, we're going to talk about network latency. And that's the red lines here, right? It's the network traffic that's happening in between your cloud data sources and the Power BI service, or in between the on-premises data sources and the gateway and the Power BI service, and also between the clients which are talking to the Power BI service, right? So this is an example of where this could be problematic. Suppose your Power BI service is hosted in the eastern US, and but your on-premises gateway and your on-premise and your data sources are in Australia, right? So every time a client comes, every time a client goes and connects to the Power BI service, the Power BI service is going to be making calls to Australia, and it's going to be taking those round trips, which can end up taking a lot of time, right? So best practices here: one, definitely use Power BI Desktop to help you gauge network latency, right? Because as we mentioned before, Power BI Desktop typically is going to sit on premises, right, fairly close to your on-premises data sources. And so if something is being very slow in the cloud, but Power BI Desktop is not being slow by virtue of being very close to the data source, then it's a very strong indicator that you have a network latency problem. Another thing you can do is use Azure Speed Test, right? So Azure Speed Test is a tool that we have, is a web app, which basically says, particularly for the current client machine making the requests, it tells you the latency between that machine and the different instances of Azure that we've stood up. So here's another great indication, right, that network latency might be a problem, is if you have a client machine and you're noticing very high latencies against the instances or clusters of Azure where Power BI is currently hosted, then that's an indication that you have a network latency problem. Okay. Our second best practice is the following, which is to make sure. So if we back up, there's a few things you can focus on in terms of network latency, right? There's the client talking to the Power BI service, which can take a while, but there's also the Power BI service talking to the underlying data sources, right? So it's kind of the right side of the screen versus the left side of the screen. And our typical guidance is, if you're going to focus on reducing one thing, focus on reducing the latency between the Power BI service and the underlying data sources. And the reason for that is, if you have a single request coming in from the client, that can result in multiple round trips between the Power BI service and the underlying data source. And so your efforts are much more highly leveraged if you focus on the left side of the screen rather than the right side of the screen. Right? The picture on the right here shows that if you go into the About section in the gear in the top right for Power BI, you can see where your current instance of Power BI is hosted. Naturally, the question that arises from this is, well, if my Power BI instance is hosted somewhere which is far away from where the rest of my data is, can I request to have it moved? The answer for this, unfortunately, is no right now, but we're working on it. Okay? So actually, just to back up a second, one thing that we do advise, right, so thinking about how we can actually reduce network latency, one thing that we've seen work for a lot of customers is if you find out that your Power BI instance, that network latency is your problem, and you say have an on-premises data source, you can consider spinning up a VM in or more close to where the Power BI instance lives, and put your on-premises data sources there, put your gateway there, and by doing so, you'll reduce your network latency. We've seen that have really good effects. Now, if that doesn't work, or if that for some reason isn't viable, another option here is to use Azure ExpressRoute. Right? So Azure ExpressRoute is a way that you can more tightly control how the network traffic flows between your on-premises infrastructure and the Microsoft infrastructure that's hosting Azure. Right? So without Azure ExpressRoute, what you're going to see happen is that network traffic is going to go along the public internet. You're not going to have much control over what nodes it jumps to, and it could end up taking a very long time. Whereas with Azure ExpressRoute, you're going to be able to create more direct, have more control over the connections there. So working with one customer, we actually saw, I think, something like a 2 or 3-fold increase, or decrease rather, in network latency when we deployed Azure ExpressRoute. But here again, this is more of a more extreme option if the VM route, well, if a network latency is an issue, and if the VM route isn't working for you. Okay. So finally, we're going to talk about some all-up guidance. And so one thing that we haven't really touched on yet is the final component of the performance, which is slowness in the Power BI service itself. And so there, one thing I will say is that we have a squad of engineers dedicated to improving the service, performance in the service rather. And this is something that we're constantly focusing on. But there is in addition, there is a good amount of guidance for reducing for kind of tuning your performance inside the Power BI service if the service itself is a problem. So that's really if you've narrowed down all the other different factors already, and things are still being slow, or if the issues aren't with your data source itself. right? So this first one's kind of cheesy, but obviously you're going to want to make sure you limit the number of visuals in dashboards and reports, right? What we saw before, again, that multiplicative factors, like if you, as you grow the number of tiles, you might be scaling the load on your data sources in a multiplicative, it's tough to say, fashion, right? The next piece of guidance here is put custom visuals through their places, and this is one that we actually see a ton, which is custom visuals are great. If you guys don't know, there's a gallery online where users can submit their own custom visuals. We see a huge amount of uptake for that. There's a lot of great visuals that the community has created, and also that Microsoft has created. But sometimes what we see is that these custom visuals under certain loads, under certain conditions can actually be very slow, and they can end up impacting the performance of the entire dashboard all up. And so here a crucial piece of guidance for us is if you're going to be using custom visuals, go for it. They're an awesome feature, but just make sure to test them ahead of time, right? Make sure to go into the service yourself, click around on filters, click around on the slicers, and just make sure that your data is updating at a good pace. That's another key piece of guidance. The other thing I failed to mention with the first bullet point is one feature that's very popular for us today is pinning live report pages. And so that's the functionality where you can go to a report and you can pin the entire report to a dashboard. I think something like 25% of all of the tiles that are pinned are of that type. Now this is a great feature, but this also comes with some performance implications. In particular, these tiles tend to be much slower than the other types of tiles that you see, and so you're going to want to make sure you limit the number of live report tiles you have on your dashboards. There's less than 2 or 3. Well, I guess that's 1, but less than 4. So something else to keep in mind. In addition, especially if you set up a direct connection to an external data source, you're going to want to make sure and things are being slow, you're going to want to make sure to set and save your filters on the reports. And so in this case, right, if you set a filter on the report and you save it, what that's going to do is scope down the query that's sent to the external data source. And in doing so, it's going to reduce the amount of traffic that's going through, and it's going to tend to speed up your report significantly. And of course, if you pin those visuals to a dashboard, the pinned visual will remember the filter that you've set, and so you get the same performance benefits once you have it in the dashboard. Okay. Here again, be sure to, if performance is an issue for you, take a look at the measures and the aggregates that you've built in the data models and scope them down if necessary, right? Ask yourself, is this really necessary? Especially if you're making these queries to an underlying data source, these can tend to bog down the data source significantly. Okay. And finally, this is not so much one with the Power BI service, but this is just general guidance, right? If you've set up an external data source, make sure that you do load testing on it based on the concurrency that you expect from your data source and from Power BI. Okay. So what we have in the deck as well is a bunch of additional resources to help you guys out. There's a walkthrough, for example, on setting up gateway performance monitoring. There's a few white papers we have already that kind of show off the deep internals of the Power BI service, right? So what the Power BI service is actually doing when you hit it, how it's channeling your requests through AAD, through our front ends and back ends. There's also a lot of information out there on SSAS performance tuning, and also on direct query performance tuning. So be sure to take a look at that and kind of do some further investigation. All right, great. So that kind of concludes the formal part of my presentation. I'm happy to take questions. But first, right, visit Channel 9 to get some more information. Please evaluate this session. Check out the Microsoft Virtual Academy. And of course, you can win a Spark After Dark drone pilot pass by completing your session evaluation. And remember to collect your wristbands. Thank you very much. Any questions? Right here? Uh-huh. Ooh, that's a good question. So let me make sure I understand. So you're saying if you have a direct query connection with a data source and you want to create a new calculated column, is it beneficial to do that in the data source itself or to have Power BI do it? Is that correct? It's a great question. The answer, I think it depends, right? It's tough to make blanket statements about direct query because it goes to so many different data sources. Is there a data source that you have in mind in particular? Azure SQL Server. Yeah, that's a good question. I think I would want to say that setting this up in SQL Server itself might be faster, just because you're kind of sitting closer to the data. You don't need to wait for the overhead of Power BI. But I think ultimately the answer there is going to be make sure to test this out yourself and do a little bit of experimentation. Because I think even with Azure SQL Server, it's going to vary depending on the circumstances. Yeah. Yes. So the question was, I mentioned that there's a limitation on how you couldn't move where your Power BI cluster is located. Is that on the roadmap? Is that correct? So yes, I give this answer all the time. Yes, it's on the roadmap, but there's no ETA for it yet. What we do, so we do hear this request a ton, right? As you can expect, people sometimes do find out that the cluster is in the wrong location and they ask to move it. It's just very challenging technically, right? How do you move all that data from one region to another while still maintaining uptime, while making sure nothing breaks? So that's kind of why we can't give an ETA for it yet. So the question was, is it best to have a SSAS instance dedicated to Power BI, right? And then as opposed to having one that's kind of for Power BI and also any other operational needs that you might have? Is that correct? I think the answer depends. So we've seen some deployments be very successful with a dedicated instance of SSAS. And one of the reasons is that Power BI tends to put a lot of load on SSAS even without user interaction, right? Every 15 minutes, you're going to be making those caching requests between Power BI and SSAS. And so if you don't want that to be disruptive of any other operations happening on SSAS, you might see a lot of success in having a dedicated instance. Does that make sense? So the question is, are we considering kind of taking an imported model and kind of upgrading it to direct query or live connection? That is something on our backlog. Again, I can fairly definitively say we unfortunately won't be able to get to it in the first half of the calendar year of 2017. But beyond that, I unfortunately can't give an ETA. Sorry, I couldn't hear that. High availability for the connector? For the gateway or for the gateway? Yeah. What was that? Okay, high availability for the data gateway. Yeah, that is something we are working very hard towards right now. I believe for the first half of the calendar year 2017, actually. Because obviously, as we've seen enterprises deploy gateways, it's been a really, really big ask for us, is to make sure that the gateways can fall over, to make sure that they have very high availability, because if the gateway goes down, of course, everything else goes with it. So something that we're working very hard towards right now, and hopefully we'll see in the near future. Here? What's the effective, sorry? Query parameters on direct query? In terms of performance? Sorry, I didn't get that. Uh-huh. Ri- Right. Yeah, here again, the blanket statement is challenging to make for direct query because it supports so many different data sources. In general, though, we've seen customers use special query parameters to a great amount of success. But as far as the performance implications of query parameters, I think it depends on what the parameters are, how you set up your database, etc. Up there? Oh, is the cloud model capability going to come on premises? Um, So that's a good question. So is the cloud model import functionality going to come on premises? I think so. There's no current plans to do that. But if you look at what's actually happening in the cloud model case, right? The service is pulling that data in, and it's basically building an analysis services model on top of that. And that's basically it. It's just that we do this for you. And so the closest thing you can do to that is essentially just send up an instance of analysis services on premises and connect Power BI to that, and you're basically getting the same thing. Right? Might be more setup cost, but there again, especially if data sovereignty is your concern, then Power BI won't have a copy of the underlying data, but you'll still get the performance benefits of a live connection. Does that answer your question? Yeah, that's a great question. So the question was, is there any sort of caching going on in the cloud, right? Even when you do live connection. So actually, as I mentioned earlier in the presentation, we do by default do that caching. And that cache does tend to live a while. And we actually have a lot of feedback from customers who are concerned about data sovereignty, who say, hey, that's not okay. And so as a result, we're actually working on a functionality right now where in the gateway, you can actually specify how long that cache lives, or even whether or not to use that cache at all. And so that'll solve these concerns, right? So you can say, hey, don't cache this data at all. Every time Power BI is hitting the service and makes that live connection, it's just going to pass the data through, but then forget about it. Definitely in the first half of calendar year 2017. Like, we're working on it right now. Beyond that, I can't give any precise dates. Mm-hmm. Yeah, that's a great question. So just to make sure I understand, the question was, with the new functionality where you can take a Power BI report, push it into SSRS, what happens if you have an import model, right? Because the import model is essentially running analysis services. I want to make sure I give you the correct answer. The feature is in preview right now, and so let me follow up with you afterwards, because I'm like 80% sure, but I don't want to, yeah, unfortunately. Here? Yeah. Yeah, that's a great question. I'm this is kind of going down one level of detail. It's certainly for tabular. That's where we're going to be kind of optimizing the queries that come in. For multidimensional, we have it on the roadmap. No timelines, unfortunately. But in general, we want to bring those performance benefits to SSAS 2016 regardless of tabular or multidimensional. And so just as a good practice for now, using SSAS 2016, regardless of how you're setting it up, will kind of future-proof you once we do make those investments. Any other questions? Yep. Do you have to do anything different from Power BI Embedded? Is the question? Oh, sorry, did I interrupt you? Any guidelines? So actually, everything that I talked about just now should apply equally to Power BI Embedded, right? Ultimately, it's a lot of the same guidance. Certainly, with the upcoming gateway support for Power BI Embedded, you're going to want to make sure your gateway has, can handle the load, handle the performance characteristics there. But yeah, I would say even though this talk was tailored for the Power BI service, all the guidance is equally applicable to Power BI Embedded. Anything else? Oh, yeah. Yeah, that's a good question. So your question was, sometimes you see when you set up direct query that the dashboard tiles aren't automatically updating. Is that correct? Yeah, there's a class of issues like that we're looking to resolve. I certainly have seen such issues before. One thing you can always try in those cases is in the dashboard, there's the more menu, and you can try manually refreshing those tiles. Sometimes that works. Or the nuclear option is just to repin those tiles, and that tends to fix it. But in general, there is a class of those bugs where the dashboard gets kind of disconnected from the underlying model, from the underlying report, and we're looking to fix those, certainly. Great. Anything else? Yeah. So the question about streaming data sets and performance limitations? Yeah, so that's a great question. So streaming is a bit of an overloaded term. So if you break it down with streaming, there's the push path, which actually remembers your data. And then there's the new streaming feature set, which is actually not remembering. We don't permanently store that data. It's just for the visuals. So when you go in the UI to create a streaming data set, you have that checkbox, right? It's enable historic analysis. If you check it on, we're going to be going through both paths. We're going to remember everything, and then we're also going to put it into the second path, which is more designed for the visuals. If we choose the enable historic analysis option, you do hit some limits, right? You can only store 200,000 rows. If you push in data too fast, we'll also throttle you. And so those are kind of things to keep in mind. If you go with just the pure streaming option, where we're not actually remembering anything for you, those limitations go away to a great extent. So you can push data to it all day long because we don't actually remember, so to speak, that data. It's not going to be as limited for you. In addition, the first path where we remember your data tends to update just a little bit slower. So there's going to be a larger delta between when you push data in and when the visuals actually update, whereas the second path, pure streaming, is going to update right away. So our guidance tends to be if you have a need to see the data right as it changes, that you go with the second route. Any other questions? All right, so I will be in the speaker lounge after this. Feel free to come up to me afterwards and ask me direct questions. In fact, actually, since we have some time remaining, I'll hang out as well. Otherwise, thank you guys very much.